Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is a video for college algebra students who are going through and learning complex numbers for pretty much the first time. Or maybe you're reviewing this topic and you're in a pre-calculus course or college algebra course. Complex numbers are kind of a weird topic in mathematics in that you learn them for one purpose only for quite some time, and that's for solving quadratic equations that have imaginary roots. And that is honestly the only reason originally you learn them. Later on, they become incredibly important. They're their own field in mathematics, and you end up using them quite a bit in courses like differential equations. So if you're moving forward through the STEM sequence, they do become important. However, you're only going to have a brief review or introduction to them in college algebra, and you're not going to see them again for quite some time. So that's a bit of an unfortunate piece because they're really fascinating. They're great in a trig course, actually. There's a little subtopic in trigonometry that focuses on complex zeros and actually visualizing complex numbers in the complex number plane. It's an awesome area of trigonometry. I hope your instructor covers that. But let's dive into a review or an introduction to complex numbers here. So this topic specifically is just expressing square roots of negative numbers as multiples of some magical number I. Let's define that. Let's see, I'm going to use a highlighter here, is defined to be the square root of -1. Now, we were taught for many years that the square root of -1 doesn't exist. However, it does exist. It's just there was not really a great use for the number square root of -1 because, well, there just wasn't a technology that used it at the time, but it's been known for centuries that that solution to, or the solution to that equation is not a real number. It cannot be expressed as a non-repeating decimal, nor can it be expressed as a ratio of integers. So it is a very special number, and we had no idea what to do with it until electronics came about. The imaginary number is misnamed for many reasons nowadays because it is not so imaginary. It's the way your computer works, the way your TV works, the way your phone works. All that stuff, anything that works on electronics basically relies upon the imaginary numbers. So anyhow, that I, which is equal to the square root of -1, is called the imaginary unit. It is an imaginary number, but that specific number is called the imaginary unit. And any number that can be written in the form b times I is called an imaginary number. B is a real number, so it could be 2i or square root of 3 times I or whatever it is. It's some number times I. And you can see right here, I write that as b times the square root of -1 just to remind you that I is the square root of -1. Any number that can be written of the form a plus bi is called a complex number. So you can see there are three levels of definition going on here. The first is a very basic definition. What is I? Well, I is square root of -1, we call that the imaginary unit. Well, what if we were to multiply that by a real number, b times I? Well, that is now called an imaginary number. Well, what if we were to add a real number to that b times I? So a plus bi. Because it has a real part to it, we call that a complex number. And we say that it's written in standard form, but really, it's just, most people are just going to call that a complex number. A, as I just mentioned, is called the real part of that complex number. B is called the imaginary part of the complex number. Finally, the set of all numbers of this latter form is called the complex number system. So all numbers of this form right here, let me circle it up, they create the complex number system. What's interesting about the complex number system is that it is a suitcase or a briefcase that actually contains the real number system. Let me say that in a cleaner notation. First of all, this C with a double bar on it, even though it doesn't look like it has a double bar, most people would write it like this. C with a double bar on it is a set of complex numbers. It's the set of, that's what this brace is, means the set of numbers such that those numbers are equal to a plus bi for real numbers a and b. So that set of numbers is called the complex number system, and it turns out that that briefcase called the complex number system is a massive set of numbers, and it contains numbers like 1 plus I, it contains numbers like I, it contains numbers like I times the square root of 3, but it also contains numbers like 3 plus 0i, or pi plus 0i. These, notice there's not an imaginary part because we've muted out the imaginary part on those numbers, so those are just real numbers. So it turns out the real number system is contained within the complex number system. So any real number you have met and dealt with in the past up to this point in mathematics is also actually a complex number. That's not important for our conversation here, but still good to know. So the piece to take away from this discussion right now is that the imaginary unit, I, is the square root of -1, and the imaginary number is b times I, and a complex number is a plus bi, where a and b are real numbers. Now, as a baby theorem here, the theorem is I squared is equal to a -1. I is the only number, well, okay, that's kind of not true, but I is the base only number that whose square is a negative. And I say it's sort of not true because obviously 3i, when you square it, becomes -9, but it's okay. It doesn't really matter. I squared is equal to -1. The proof is very, very quick and easy. Since I is equal to the square root of -1, we can then say I squared is equal to that right-hand side squared. And of course, squares and square roots, they undo each other for the most part. And this will be equal to -1. So I squared is equal to -1. That's the end of that proof, QED. Very fast proof. And again, QED means quod erat demonstratum, so it has been proven. That's a Latin phrasing that's used quite often in mathematics. The only other thing we're going to do in this video is just talk about how to write an expression in terms of the imaginary unit I. So basically rewriting this result, which is the result of a quadratic formula, in terms of I and writing it as a complex number in standard form. Let's go ahead and go through this piece by piece. First of all, pretend as though you're just facing this in an algebra course and you're asked to simplify this statement. Well, there are a couple things you can do. Work in the numerator first. So I'm going to write that as -3 plus or minus. And I'll write that square root of -64 as the square root of -1 times 64. And the reason why I'm doing that is because I know I could take the square root of 64 fairly easily. Now I'll go ahead and move down to the next line here and say that's -3 plus or minus. The square root of 64 is 8. We still have a square root of -1 hanging out there. And again, square root of -1 is defined to be I, the imaginary unit. So this will be -3 plus or minus 8i all over 2. To be honest with you, that is how most students will write it. However, you will likely be asked to write this in what's called standard form. Standard form of a complex number is a form like this, a plus or minus, in this case, bi. So you do not want to write it as a single statement. You want a real part and an imaginary part. So let's go ahead and break this fraction into a real part and an imaginary part. Remember that from our prerequisite material, our fractional arithmetic, that a plus or minus b divided by c is the same thing as a over c plus or minus b over c. So let's go ahead and break this fraction right here, break that up using that identity from fractional arithmetic. This will be equal to a negative 3 over 2 plus or minus 8i over 2. Obviously 2 goes into 8 4 times, so I'm going to write this as negative 3 halves plus or minus 4i. That is how you would simplify an expression involving imaginary numbers into standard form. Just remember, you want it as a plus or minus bi, not as a single fraction, but as a real part. In this case, the real part is negative 3 halves, and an imaginary part. In this case, the imaginary part is either plus or minus 4. All right, that's it for this video, very short. In the next video, we'll move forward and learn a little bit more about complex numbers.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at ease. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.